Sure.
Okay,
All right.
so
So let me start really quick here, then Scott. So guys, as you know, we're running a series of workshops that's specific for associate of SOU Java, and hopefully some of you guys were able to participate on TDC last week, right? Because you got tickets for everyone, and anyone was able to use those tickets, or no? You
I was in
busy,
the middle of a busy week at the work,
right?
and I have two jobs. I like Julius. I have two jobs, so that was not much time that week.
Okay, I see. I see. How about you, Thiago?
I like good practices in software development,
Mhm.
like a clean code, clean architecture, solid domain-driven design, for example. It's
Nice.
very important for the height projects.
Cool. All right. Good. So no, I'd like to thank Scott, right, for taking his time here and running this workshop for us. And unfortunately, I have right now is going on live in my channel that I'm supposed to be there, but I'll have so I'm gonna stay with you guys here for about 10 more minutes and then I have to leave. But Scott is a good friend of mine for a long time. Scott has a project that's called, the Keep Calm and Refactor project. He, one of the things that he loves to do is exactly refactor old code and buggy code and things like that. So I thought there was a perfect person to come here and talk to us about that. He has a very, very clear vision on what we need to do and how to approach code problems and things like that. So I ask a lot of questions for him, guys, and benefit from that, right? So without further ado, let me pass the ball to Scott Rushan. Thanks, Scott.
thank you, Bruno. Excuse me. So yeah, just a little bit of background. I got into this because I found myself working on code. I I remember I finally got to work on a greenfield project, and I thought, okay, I am going to get to write a program that's not going to be an absolute disaster, because every other piece of software I moved into became an absolute piece of just a disaster. And and I found out that after a couple of months, all this pristine code that I had written had become an absolute disaster. And I said, something is just wrong. I mean, I'm not making the world a better place. I'm making it worse. And so I discovered that there are all sorts of ways uh, to improve the code that you're writing. The the book we're looking at today is Clean Code by Uncle Bob, and I've subtitled it "Writing Code That You Care About," because really, people don't intend to put out crappy code. We really want to do our best. And so if you keep that in mind, even the garbage that you have to start working with, that someone else wrote or that you wrote as a different person a couple of months ago when you didn't know better, you were doing your best and they're doing their best. So so we really do care about our code, and we want to make sure that it's that it gets better. And of course, our reference book for this is Uncle Bob's Clean Code. It's been out over 20 years, and I don't know how many of y'all have read this book, or at least have it on your shelf.
We'll
So,
say 30% of it, maybe. It's here.
right. Yeah, most of us have lots of nice books on our shelves, and we've read the first chapter or two of each of them, so that's okay. But I'm going to give you kind of a, there you go. All right.
but using Portuguese, this. Sorry.
Yeah. So yeah, basically what I wanted to do is kind of give a quick overview of some of the main concepts in clean code, and then do a sort of a hands-on kind of activity of refactoring. With that in mind, I thought it would be good to start by talking with y'all about what are some of the problems that y'all run into with the code that y'all are working on. And so it's like, what sort of problems do you tend to struggle with the most? So you got someone else's ugly code. I mean, that's sort of the big problem. Somebody else wrote it, so it's by definition ugly because I didn't write it.
Right. So I'll tell you I think my biggest challenge every time, Scott. So I'm a consultant, and I join a project, and we had this event last week, and someone was saying that in Amazon they expect a developer, like a developer, to be fully productive after 8 months in the company, right? And I was like, whoa, right? Because I'm a consultant and I join a project today, right? And tomorrow they're asking, what have you done, right? So I think the biggest challenge that I have is, to quickly have an idea of the code base and what's going on, what are the main problems, where are the main issues. So that's, for me, is the thing that's is the most, is the most challenging, I think.
Yeah, that's something that's important. That's important for all of us. I mean, one of the things that Uncle Bob points out in his book is that we spend 80% of our time reading code and 20% of our time writing code. Personally, I think that's a very low estimate. I spend much more time reading code. I spend very little time actually writing it.
It's important in the teams because it's important review code. It's important good review codes. For example, short methods don't care about they don't repeat your code, for example, like this. It's important.
That's true. Knowing how to do a good code review is really important, because a lot of times it's easy to just start trashing somebody, saying, what is this? Come on, you can do better than this. That's not going to make for a good conversation.
The refactoring strategy for me, like when I start refactoring from my small method, for example, it's easy to got on a chain of, oh no, I have to refactor also this, then I go to this, and then I'm refactoring a lot of small points, but I'm refactoring like the whole code. So the strategy to analyze this code and choose from where to start and where to go, how do I plan a job like this?
Yeah.
And the point that Bruno said, I'm facing now a new company, a lot of old codes, so I have to read all those crap that is there, a lot of ifs, nested ifs, and start to understand what they are doing.
Right. Yeah, I completely understand that. You start working on one thing and it explodes into it's like the Hydra. You chop off one head and 7 more grow out. Oh no.
IntelliJ start to get a lot of red stuff.
Right. Okay. Good. Then I can bring up some techniques to help you with that as well. Oliver, do you have any things that you're struggling with that you'd like to dig into?
Okay. Hi, everyone. I
Hey.
don't know.
Hi.
I think that one thing important to write clean code is to understand the domain of the problem, because sometimes when you are writing code, or you only try to write like a solution, but you don't understand how all the concept have a relationship between each other, you result creating like a mess in your code. So I think that's important. That's one important thing.
Right.
And
Yeah.
another side, I think that it's important to use your code as kind of communication, and use a good vocabulary to express the ideas that you want. Because if you use any term or other terms to refer to one concept, you result to like confusing other developers or other people who have to look your code.
Right. Absolutely. Yes, and that's where let me see. Do I have it here? The domain-driven design. So if you understand the domain, then you can create objects that that are referred to, that the users can understand, so you can communicate more effectively with the users, and how the objects you create are going to relate to how the users actually use them. So, right, very good.
So thank you.
Okay.
I have more collaborate about code smells. For example, write the good methods for using object oriented. For example, it's important. Abstract class, for example, you returns like this.
Right. Yeah. Yeah, most of us have come from well, at least us old guys have come from a programming paradigm of procedural programs. So we just sort of write one line and then the next line, then the next line, the next line, and try and do everything. But this object-oriented thing, it's a hard concept to understand, and it's a hard discipline to maintain. And yeah, we'll be talking about some of that as well. So very good.
Maybe one thing more. I think that always fixing the basics is important, because sometimes people who are starting to writing code or development want to I don't know, like learning lambdas or things like looks like amazing, but it's important to fix the basics, object oriented programming and all the concepts that are behind that. Because if you don't understand what are you doing, and you're just using like Spring, and you don't understand how MVC works, for example, I think that can cause a lot of problems.
Right. Yes. Yep. And that's really what this this book is about. Is these are the fundamentals that we need to know. There's a quote that here, this one from Kent Beck, that's just it's one of my favorites that I keep going back to all the time. I'm not a great programmer, I'm a good programmer with great habits. So if you understand the fundamentals and you're able to put the fundamentals in place, everything else starts to fall into place, and your programs end up just being better, more maintainable, and other people can understand them better. So, and it's all about the fundamentals. Okay. So so we have a nice list of things to discuss, and I'll make sure to cover this in what we're going over today.
So,
Yes.
Scott, would you mind making me a co-host? Because then I can see if there's anyone joining in.
Okay. Let me see how to do that.
Yeah, just go to the participants and then you can click on more and make me a co-host.
Aha, look at you.
Guys, in my opinion, it's important test drive development also using a clean code, for example, for write a good practice in software development.
Right. Absolutely. Well, Bruno has just made you the host. So
Yeah, I'm already letting people in.
okay.
There's several people in moderation here, so I'm letting them in.
Oh, okay.
Hello, everyone. Have a good evening.
Hey, Max, how you doing?
Good day, sir.
Oh, hey,
Martin.
Scott. Hey,
Good to see you.
hey. Yeah, it's amazing to see you here too, as well. Congratulations for international track yesterday
Oh,
to DC.
thanks. Yeah, that was fun.
I love it. I learn it a lot every time.
Excellent. I'm glad you were able to.
Oh, great.
So Bruno, can you give me the ability to share my screen? You are muted.
You made me host, man. You're supposed to make me co-host, not host.
Well, I didn't have a co-host option, so
All right. Well, okay. So now, oh, why you don't have the co-host option here?
I don't know. I didn't do anything right in setting this up.
Okay. Anyway, so yeah, so you can share the screen now. So I'll keep an eye on everyone that's joining here, so you don't have to, Scott.
Okay.
And then but I'll be here in the background.
Yeah, and when you have to go, you can just make me host again, I guess.
Yeah. Okay. Cool.
Excuse me. All righty then. So, yeah, there was the other quote that I had in there. Basically, our question of what is clean code. You know, basically, and that's what my my first little slide there, introductory, said. It always looks like it was written by someone who cares. And if we can remember that the reason that we do things is because we care when we want to make the world a better place, then and most other people are that way as well, then it helps us to do better with our code reviews and with our just looking at someone else's legacy code and that we've tried to put together. Yeah, before I go on, I wanted to ask you real quick, Max, is there, we were talking about just issues that we run into that we want to address. I want to make sure that I cover things that are useful for the people who are here. Is there a particular problem that you run into more often that you'd like to discuss that we can make sure we cover it?
Oh, well, it's up to you, man. I think that it's so valuable for everyone. I think so. Oh God, you catch me now.
Oh, okay. That's okay.
Take it away. Take it away.
All right, not
I
a
don't
problem.
want to.
Will do. Okay, so so let's start moving ahead. Kent Beck, he's sort of, well, he's the one, he was one of the original participants in the Agile summit, where they came up with the rules of what Agile practices would be. And he also invented JUnit and the idea of unit testing. And so, and he's got these 4 rules of keeping your code simple. First, it has to run all the tests. Of course, that assumes that you have tests, and those tests are more or less complete. One problem we have with working on a legacy system is that there are no tests. I'm working on a system of close to 700,000 lines of code. And when I joined, there was, I would say, about 50 lines of test code that wasn't ever run. So when I did run it, it didn't work. So I'm sure I'm unique with that problem, that you've never had this sort of thing, that you work on systems that people are working hard to make sure the tests are updated. But just in case you're not, we will be discussing a little bit about that. Now, code that contains no duplication. This really, this recognizes our tendency to use copy and paste to write code, right? I mean, it's only natural. You need to add this particular function. So you find something that does something similar, and you take that piece of code, you copy it, and you fiddle with it until it does what you need it to do instead of what it did before. And so we tend to have a lot of code duplication when we do that. So it's important that we go back and refactor that to get rid of the duplication when we do that. Expressiveness, expressing the intent of the program. Expressiveness, it's really about being clear, making sure that the code is easy to understand for the next person who's got to come in and read it, which may well be you 2 or 3 months down the road. And finally, the minimizing the number of classes and methods. That's kind of a balance. You don't necessarily want to clutter your system with hundreds of little tiny classes, but you also want to avoid the God classes that they get passed around everywhere. And then you start having the tight coupling that makes code hard to maintain. And I think you find that balance in what's called the single responsibility principle. And so in short, you want a class to be responsible for a single function or set of functions so that it's not being abused, and then again you fall into the God class with a tight coupling everywhere. The bottom line of all of this is that you kind of want to follow the Boy Scouts rule, which is, you leave the campground cleaner than you found it, and you leave the code base cleaner than you found it. If you can go in there and when you make some change, you can clean it up and leave it a little bit better, then it will slowly, excuse me, slowly but surely improve and become a more effective piece of software that frankly is fun to work in. So let's start with naming. That's probably the hardest thing we do when we're writing code, coming up with a good name. And so really the first thing we need to think about when we're naming something is our intent. What does this variable represent? If you've got int a, that's meaningless. But if I have elapsed time in days, I'm really, really clear about what that needs to be. I don't have to put in a comment explaining what a means. Or if I have a string that's a team name, that's clear and that's understandable. And some people will even consider this to be what's called primitive obsession, where ideally you'll have a class that represents elapsed time in days. And that will have built-in validation to make sure you don't have a negative number there, or that you don't have, too many days in there when it's meaningless. And same thing for like a team name. It'll have validation that, it's got the right format, that it's the right length, and will fit in whatever our database field is. So ideally, you'll have your variables named to be something useful and have a value that is, or I guess it avoids the primitive obsession code smell. Same thing for collections. You know, we may just have our default collections that we use, but if we give it a useful name, you know, like country names, then I know what's in that collection and what it's intended to be used for. Customer orders, I know who that's for, and I can see, okay, that's a map, so it's going to map an order to the customer, so I can find whatever customer is associated with this order, that sort of thing. So the naming is what makes it useful, and you're able to move forward with, I guess, make it more readable for the people who are having to read this later. Sometimes it's important, certain entries in a collection are meaningful. So you can give it, like if it's in an array, you can give it a subscript and give that a constant value, so that, you know, if I've got a collection of components and I can say, okay, yeah, whichever one is the main window, I need the width of that so that I can properly, you know, put up my dialog box or something like that. So if I can have instead of having some magic number, I can make sure that I have a constant that specifies that. Same thing, like, you know, if I've got a bunch of users and the admin user is 0. Well, 0 may be meaningful to the guy who wrote it, but to the next person who comes along, I don't know. What's that 0 mean? Well, now I know it's an admin user if I set a constant for that. Another question we might ask, how would I use this collection if it were returned from a method call? Okay, so I've called some method, it's going to clear the inactive users and it's going to return the users that were cleared. Okay, that would be I would then go and give this a useful name so I know what to do with this in the future in case I need to do something with those inactive users. I need to also remove them from the database or something like that. So so we choose names that are not only honest, but they also display the intent. Well, let's talk about honesty here, okay? So don't call something a widget list unless it's a list, okay? So if I'm going to do customers and call it a list, but it's really an array. This is many years ago, we had the concept of Hungarian notation. I don't know if you've heard about this, but it's where you kind of stuck the type of the object in with the variable name, and it was abused everywhere. And so that's where we get this sort of thing. You get a customer list when it's really an array. And what's better is having a, you know, customer list and it's actually a list. But actually, even that is a bad idea, because maybe at some point you might want to turn this into like a set, so there's no duplicates. So instead of having a widget list, just say widgets. All right. So instead of getting your customer list, let's get your customers, and that way we don't know or care what the collection is. We can just let our IDE tell us which accessors we're going to use. Don't abbreviate names. So if I'm going to have a custlist, I don't know what a custlist is. That could be, who knows, 1,000 different things. It will definitely be confusing. And with our IDEs these days, we're not limited to Fortran's limitation of 8 characters for a variable name. We can have them be as long as we need to. So make them long enough to be useful. Yeah, don't give 2 values. If you're like comparing 2 values, don't give them number 1 and number 2. They're different for some reason. So put that in the name. If I'm doing a comparison between customer 1 and customer 2, well, one one must be, okay, I'm comparing this new customer and seeing if that customer already exists in my list. So I'm going to compare the new customer against the existing customer. That's much better than customer 1 and customer 2, because who the heck knows what that means? Finally, let's look at naming clarity. You know, it's important that we're not clever. You know, Unix, Linux has this, it's just filled with all kinds of clever names that get to be really irritating. So way back when, we started with more, and more makes sense because you're going to have a list, you're going to display a listing on the screen, and you hit the space bar, and so it breaks it up in more. Well, then we got clever with it, and we came up with less, which was a more powerful more. So you could scroll backwards if you wanted to. And then we came up with something even better. We call it more, but we spell it with a different way because it's better than more, and it's even better than less. And then, of course, that's not good enough. We have most. So this is like the ultimate more. Well, just stop. Just stop. I mean, more, forget it. I'm just going to use more. I don't even care what your clever name is, because I can never remember which one do I need to use now, unless I wrote the doggone thing. So, and the same thing with variable names. Don't go getting clever with your variable names, because they'll make sense to you. They'll be amusing to you, but everybody else is going to get frustrated and will not enjoy the joke. This is one of the basics. A class name should be a noun. Class name represents an object, which is a thing. So don't, you know, if you're going to have to regenerate characters, and this class is going to do that, then don't call it a character regenerate class, because that doesn't make any sense. You can have a character health class, and then it can have a method called regenerate, but you don't want to give a class a verb as a name, because that will just confuse people. Method names are verbs. So methods are things that perform some action. They're going to make some change or do some processing. So instead of saying character health is set to new value, how about we increase the health at a particular growth level? So our character will be getting healthier in a specific way. We want to use a single word for a single concept. We want our variables to represent a single thing. All right. And we also, if we're going to have a specific function for a method, you don't want to have for each different type of character different commands for how you're going to destroy it. Okay, so the monster is going to annihilate it, the wizard's going to destroy, the archer's going to kill, and the warrior is going to eviscerate. This is crazy. Pick one and stick with it. Use it for everybody. You find this a lot when you're working in older code, especially large code bases that have a bunch of people working on things, because they don't know that there already exists a function that does what I already need it to do, and I give it a different name. This is a great way to find a function that's duplicated and just go and refactor that into a single name. So this is one of the things that Oliver brought up, the domain. Excuse me. I'm sorry, I'm recovering from the flu here, guys. So the domain is important. You want to use terms from the solution domain that will make sense to the users, so that when you're explaining how the program should work, it's more easy to translate the user's requirements into how the program needs to implement those requirements. So we can probably guess what item.put of value means. We're going to stick a value into a list of items. But that won't be meaningful to the users. If, on the other hand, I've got set of new tissue samples and I want to attach a chemical analysis to it, then that would be more meaningful to the users, and we'll be able to, when we explain to the users what's going on, they'll understand what's going on and whether or not it's operating the way it needs to. You want to group related variables into a single class. Again, this goes back to our object orientation discussion before. When we're doing procedural stuff, you'd have a username, and then you'd have a user age, and then you'd have a user address, and you'd have to keep track of all of this. And you'd probably have it in a single, source file or header file that you'd pass around or something. But now we've got an object. So you just say new user, and he'll have a name, age, and address all together in one place, so you know where to get it, and it stays consistent. A lot of times, this is another throwback to us old guys. The namespaces shouldn't collide if you're using a package. So you shouldn't have to have like your Microsoft's artificial intelligence user. I'll include my org should have been com. Oh, anyway, my org.ms.ai package, and that way my user won't go and crash with anybody else's user. I can make sure I'm using the right one, even though it's got the same name. That's okay. That's the wonderful thing about object-oriented programming. Okay, so that's the importance of naming variables and things. Let's discuss how we approach functions. So let me bring up some source code to look at this. There's my favorite example code that I use for bad code is this project called Slide. That it's a Reddit reader written for Android, and it's just it's got this wonderful class here with 4,700 lines. I know that none of you work on anything like that, but I've got a number of classes like that in the code that I work on. So we go to line, what here? We look at this here code, this on options selected. We see that it starts at line 559 and it ends at line 812. This is a great example of not keeping it short. It's trying to do, it's this big, long, massive case statement that does a whole bunch of different things, and it's hard to keep track of it because it's just so doggone big. One thing I wanted to point out to you, I've got this this plugin here that's called Code Glance Pro. This is a neat little plugin for IntelliJ that it sort of gives you a thumbnail of the structure of the code over on the right side. I like to promote it whenever I can, just because I find it to be really useful. So there's a little free advice. Okay, we want to make sure that we're only doing one thing at a time. So like if you look at this code here, we've got this this particular case. We're going to create this builder class. We're going to build that up, and then we're going to go and check to see what kind of page it is, and then based on that, we're going to figure out how to create a click handler, and then we're going to go and set some text on it, or otherwise we're going to set some text in a different way, and then we're going to show it. Like, this is doing a whole bunch of different things just in this one switch case. This is something that needs to be broken up into another method or set of methods. Also, we look at we want to keep one single level of abstraction. So we can look here that we've got this, we're going to get this adapter, and from there we're going to get the current fragment. We're going to cast that to get the posts, and then get the posts from that. So that ties these objects together to be very tightly coupled, because you're digging so deeply down into each of these objects that that there's no way to separate them out. It makes it very hard to break out the objects into something that's more maintainable. And then, you know, you want to generally avoid switch statements, and you can see that this is one big, long, massive switch statement. 562 to 811. That's 250 lines of switch statements, all doing a whole bunch of different things. It's just not readable. So, you know, you want to avoid switch statements and follow the these are your fundamental rules of handling functions. When we're dealing with function arguments, you know, you want to, fewer arguments is better. The more arguments you have, the harder it is to read, and the more likely it is that it's going to be doing more than one thing. If you have more than 2 or 3 parameters for calling a function, you may want to turn that into a parameter object to make it easier to pass the parameters around together. And yeah, if you're going to use variable, you know, var args, then you know, that variable argument would count as one. We go to here, you can see how, like, for this, it's got 1, 2, 3, 4, 5, 6 parameters, and there are annotations on each one, and it's just not readable. You got to sit there and stare at it for a while, and there's just 7 lines of code in this function, and it's got that many parameters. It's maddening. So there's a reason why this product is no longer maintained, because there's this kind of code throughout that it's just hard to understand and hard to fix. If you look up here, they do some things right, some things that they're trying to clean it up. Like, they create this builder here for setting all the different parameters they might need to for this custom tabs intent. So this at least makes it more easy to understand what it is they're trying to do when they're setting 8 different parameters at one time. So so that's how we write good functions and keep our arguments few. Properties, that would be like your class variables. That's the object oriented term for your class variables. So you know, for a function, your function name will be a verb. Ideally, it won't have any side effects. A side effect is where it changes a value inside the object. With that being said, you want a function to either do something or return something. You don't want it to do both. If you're going to have it return a value, you really don't want it to be doing some sort of changing of data, some whatever side effects in that object, because that will be confusing to the user. You want to use exceptions instead of return codes. This is another fallback to what us old guys used to do when we're writing procedural programs. Is you'll make a function call and then you'll have it return a value of whether or not it succeeded, that sort of thing. Object-oriented programs use exceptions, and they make our code much easier to write, much easier to follow, and you can handle the problem in a place where it actually makes sense to handle it. And finally, don't repeat yourself. We're wanting to get away from duplication. I will say that that this particular object has followed these rules pretty well, except for this function here where it catches the exception, ignores it, and then returns the status, which is just defeating the whole purpose of using an object-oriented language. But for the most part, this particular class is defined well. It doesn't. The functions are all verbs. Open externally, get session, copy URL, crossboth. There aren't side effects in here. It'll either call a function. You see that it returns. It returns a void if it's just going to be doing some processing, and here it's going to be returning stuff. This isn't making any changes. It's doing a computation and returning that session. So anyhow, these are good. One problem we have with this main function here, one of the reasons I like this this little dude on the right, this code lens, is that you can quickly see that this piece of code it sort of has the same shape as this piece of code. And so if you look here at it, you can see that, okay, this is a settings is pro get current fragment. And then we've got this alert builder pro upgrade thing. We go down here and we've got our get current fragment, and then down here, pro upgrade message. So this is doing the same thing. There's probably one or two differences. If we went and looked at it, we could turn that into a function that we could separate that out and get rid of a lot of duplication there and get rid of, I don't know, probably close to 100 lines of code in there. Okay, so comments. Comments are one of those things that make it really easy to clutter up your code. And Brian Kernahan and PJ Plowger are the ones who wrote the original C programming language. And they said way back when, don't comment bad code, just rewrite it. There's a quote from Kevlin Henney that says a common fallacy is to assume that the authors of incomprehensible code will somehow be able to express themselves lucidly and clearly in comments. So basically, if you can't write code clearly, you're not going to be able to comment clearly either. You have to be able to express yourself in code. We have to think of comments as sort of a necessary evil. You'll use that to explain why something has to be the way that it is if it's not obviously clear the way it is. You can't use comments to make up for bad code, and you want them to explain, like I said, this is the intent of what we're trying to do here. I know it's not clear, but this is why it is. Or they warn of consequences. They can say, if you don't set this variable here, then bad things will happen, or make sure that you call this function before you call that function, just because that's the way the system is set up. And to-do comments are also helpful. You can use those to remind yourself that I need to go back and clean this up. Another thing in comments, you don't want to use a comment when a function or a variable name properly defined will do the same thing. And this is sort of a pet peeve of mine. Never check in commented out code. If the code was there, then it if I need to get it, I can always go back to my source code control and get the old code that was there that I've commented out for whatever reason. I can go back and find that. That's why we use Git and Subversion and that sort of thing. A lot of times we use Java docs to explain stuff. And if you don't have a public method or function, you don't really need a Java doc for that. That just kind of clutters up the code. And you also don't want to add a comment for Bob made this change on September 5th, 1995 to fix bug number 8533. This is another thing we used to do back before we had source code control. This is what Git is for. You put that sort of discussion when you check it in. Let's see here. I wanted to show, where is it? Here, if you look at how Oracle does their which is it's licensing, and then they go and have the import statements that go on forever. And then this is your Java docs. So you generally want to avoid having these big long comments at the beginning, because they just make it hard to read, and your IDE will generally make it easy to just collapse all that. Hello. I guess it doesn't do that if you're in presenter mode. Okay. Thank you. All right. Anyhow, so let's see here. When we look at formatting our code, we want to format it to make sure that it's readable by other people. Ideally, your code will read like a book or a newspaper article. Uncle Bob says that lines should be 80 characters wide or less, but he's an old fart. And really, and you can see how, if you look at how, well, I guess it takes it off in presentation mode. So if I go to get out of presentation mode, you can see that that I've got this line here in IntelliJ, and my screen's relatively dense, but it's not that huge. And this is line 120, and I still have half the page wide open. Thank you. So so yeah, it's this is kind of handy to set, but yeah, keep your lines at about 120 characters wide or less, and then they'll be able to print off better and just be easier to read. And you want to skip a line between the functions that you write. So go back to our presentation mode. You see that this one here, you can see that between every function, it's got a blank line. So that's actually one of the things they do well here. You can break up your programs. Also, IntelliJ helps you with that they've added this new extra line to sort of explain how things are being used. So also, you want to declare your variables close to where they're being used. And you want to have your member variables up at the top. So if I go up to the top, these are all my member variables. And then any variables that I'm going to be using in the object, like I'm not going to use this until the end. So I keep that, I go and define it right down here at the end. I don't have to have it way up at the top. Some people go and declare all their variables at the top, and then you're looking all over trying to figure out, okay, why is this up here? Put it close to where it's used. It's easier to understand why it's used there. Keep your related functions together. See, he's got an open URL, open externally, copy URL. So they, well, I guess launch market. So he's put the functions that are more meaningful next to each other. And finally, we talked about this before with the law of Demeter. We went to, hello, right here, where they'll have all these. If you got more than one or two dots on a line, you're going to be confusing people. back to formatting. You want to be consistent with your indentation. Make it spaces, 2 spaces, 4 spaces, 8 spaces. Pick one. Use it everywhere. If you're going to change it throughout your code, then it's going to be hard to read. The nice thing about a lot of your whatever your tools that you do your sorry, my vocabulary just went away. When you check something in, it automatically does the build. Your CI system, it will go and you can have it go and go through your code and make sure that it follows a standard format that your team has defined. And you want to follow the pattern of the rest of your team. If you start doing things, I worked with a guy who used to go and say, yeah, I made your code readable. Yeah, you made it readable to you, but you changed it from how it works for everybody else, and it would just drive everybody crazy. I know you don't work with people like that, but these are the kinds of people that I work with. We talked a little bit about this when we're handling errors. You don't want to return a status code. You want to throw an exception and make sure it's a specific one. You don't want to just throw exception. That's or throwable, which is even worse. I mean, it's just, you have no idea what to expect. If you have an exception with a specific name, then that makes it easier for the next guy who has to go in and figure out why this exception was thrown to go in and clean it up. You don't want to pass you don't want to pass or return nulls. One of the that's a code smell. There's a concept called a null object, where basically you'll have an object that is uninitialized and can be used where a regular object would be used, and it would just be ignored if it's not necessary, or if it doesn't have useful data in it. And that's a much more useful way to do things than if we're passing nulls around and throwing null pointer exceptions. We want to be careful when we're using third-party libraries. So you want to basically, for instance, we had this log4j problem come out some months ago, and it caused all kinds of problems, and everybody had to go and completely redo how they were doing their logging because the log4j was causing problems, and it was insecure and all this sort of thing. Companies were just up a creek trying to clean this out. If you wrap how you interface with the third-party object, then that sort of thing would be handled in whatever your wrapper classes are, in just a handful of places, and you wouldn't be stuck with this third-party library that does insecure things. Writing unit tests. A lot of times, we were talking earlier about how a lot of times we get into code, we don't know how it works or what it does. We can write unit tests to exercise the API and figure out how that API works into the object. And that's a handy way to use unit tests and to add useful unit tests for code that you're trying to get in there and fix. And just in case you didn't hear me the first time, don't pass null and don't return null. Okay. When we're writing classes, you want to keep them small. You don't want to have these massive classes that are, see, how long is this? 4,713 lines. This is actually smaller than it used to be. There's no way that you can maintain this. It's crazy. You want to, follow the single responsibility principle. You want one class to do one thing or one set of things. If you've got 5,000 lines of code, chances are that it's doing more than one thing. Again, I'm harping away. Just avoid nulls. There's such a problem. And you want to design your classes to be changed. You want to oh, I forget the principle that this is. Using Swagger to document the API or Postman. Yes, that's true. That's one of the advantages of using a tool like Swagger is that you get the API documented by doing that. And but if you're not doing like if you're going to be doing an internal API or functions that are calling one another, that's where the unit tests will. That's really the only way to do that sort of thing. So you be practicing for that. You want to create your classes in such a way that you'll extend it, or you'll use this class in another class, rather than go in there and change a class when something else is when it needs to have some new functionality. The best part is seeing an optional T being used with an entity.orelse. Yeah, or else no. Oh my gosh. Oh, that would be so intensely frustrating. Someone does not get it. They wanted to show off that they knew this cool stuff. Okay, so I've been going on for almost an hour now. Did anyone have any questions or comments or discussion they wanted to dig into here?
Well, Scott, I have a question.
Okay.
You mentioned about the switch statements.
Mhm.
Hold on, my youngest son want to. You say hello to him, to them. Say that.
Not a problem.
Hold on. What do you want?
I like this big old nasty switch statement that runs on for how many lines is that?
Yeah. No.
250 lines.
I'm back. I'm back. Sorry. No. My question is, we have seen that Java did some improvements on switch statement syntax.
Yes.
So, and that allow us to use data program-oriented program, for example, using records and something like that in order
Right.
to use those things, or maybe calling a lambda on the right side of the switch option. So do you think that it could be make it more readable than before this changes? I think so. Am I right? So what do you
Right.
think about this new syntax?
Oh, I think, well, it's designed. There was an article I read a couple of weeks ago. It was specifically designed to handle a database interface called data-oriented programming, I think it's called.
Yeah, I think so.
Right. And so so that's really put in place to facilitate simplifying how you access your database. So one thing to remember is that Uncle Bob's rules are not laws that that you're a bad programmer if you don't follow them. But if you're a new developer, it's more important to follow the rules until you get to the place where you know when you can break the rules. So if you have, like, for instance, if you're doing a SAX parser, I don't know if you're processing XML, and if you got a SAX parser, then you've got 3,700 switch case statements for all the different, type of attributes you can have in an XML file. And yeah, you could break those all up into objects, but chances are slim that that would make it more easy to read and more easy to maintain. Maybe, maybe not, but it depends on how you've got everything structured. But a lot of times, most of the time, when you find yourself having deeply nested if statements or big switch statements, that is an object crying to come out, and you can break that up into your what's that object-oriented thing called? Polymorphism. There we go. Hey, Thiago.
Scott, I have a question for you.
Sure.
What percentage of test coverage do you think is important for a good coach?
Well, I mean, you want to aim for as much as possible. I will say that if you're working on an older system that doesn't have tests, it will be nearly impossible for you to have enough tests to get 100% coverage. And even if you do have 100% coverage, that doesn't really mean that you're exercising every possible case. So with that in mind, you want to make sure that you are exercising all of the most important paths through the application. So, I know that a number of companies will go and insist that you have at least 80% test coverage. I mean, that's not a bad rule of thumb to aim for. But if you can make sure that you've covered all of the key paths through the program, then I think that that's good enough. That will at least give you a quick smoke test when you're putting out a new release, and make sure you haven't broken something in regression testing. So, especially if you're, like I said, you're working on an existing system that's a few 100,000 lines of code, and you're just not going to be able to cover it all with tests.
Okay,
Now, if you're
thanks.
developing everything with TDD, then you'll have full test coverage, and you can put a star on your collar. I'm sorry, I didn't mean to interrupt you.
Really, I agree with you.
Okay, very good. Yes, sir, Max. You are still muted.
Oh God. Okay, I'm on. Okay, so yeah, well, regarding this, of course, back into the sweet conversation. Okay, I know that we have discussion about code coverage, but as you mentioned, that when we see a huge switch statement, we used to feel that polymorphism is not used on there. Maybe the people needs to work better and to get the code in a good shape. It's pretty similar to a huge if constraint when
Right.
you use if and another condition in your composition. Maybe you could extract those things and create a single method that could encapsulate the logic in order to make those things easier.
Yes.
And so looks like it happens when the developers doesn't understand very well the polymorphisms or the OOP principles. I think
Right.
so maybe if we try to bring this concept in a bad way, maybe they will feel the smells that code will show up.
Right.
Right. And also, I think that the TDD can show to us if the code is hard to maintain, because when you are writing the code, it's hard to set up the scenario that you want to test. So when the people trying to test those things, and it goes against the code coverage that Thiago said. So because they realize that, okay, we got 4, 5, 3, 4, 6, 8, 10 conditions to accept and to test. And sometimes it's so hard. So maybe jumping to the question of the Thiago, maybe we need to focus on a test that can have else issues, have else failures, because if the test pass, it doesn't bring insight to you. Maybe if you change the code, anything can happen because you don't test it. So
Right.
but I don't know if you agree with me. Maybe we need to bring the OOP principles or OOP statements in order to let developers, beginners developers, to understand. It goes against the principles that you mentioned. They keep it simple. Don't repeat yourself, because it's very near to. So that's it. So thanks for bringing this concept to us.
Sure. Sure.
Thanks.
Well, like I said, object-oriented principles are complex, and we can look at it now, having worked in it for some years, and say, okay, yeah, this all makes sense, and I can see how it hangs together. When you first learned about how object-oriented stuff worked, it was mind-blowing, and you spent a lot of time. I mean, maybe you're smarter than me, but it took me a while to get this stuff figured out. But now that I understand an object-oriented way of thinking, I know that it's really designed to help me separate things out. And so if my tests are hard to write, that's an indication to me now that, okay, my objects are not properly structured. So they're either too closely coupled, or I've got a God object here that I'm passing around, or there's, if I've got to go in and do all this initialization just to get to the point where I can open up this class and make a method call, there's probably something wrong there. Or if I have to open up the database, make a connection to the database, get a pile of data so that's in a particular format, so now I can go and start doing my test, who's going to wait for 15, 20 seconds for 37 tests to do that 37 times? Nobody. It's crazy. So you've got to find ways to use your mock objects prudently. And that's another thing. If you find you're creating a set of 5 or 6 mock objects that you've got to go and get initialized so that you can run a test, again, you've got your objects are too tightly coupled. And it's important to notice that and start breaking things up the way that makes it easier to maintain, makes it easier for other people to understand. And when you do that decoupling, the code becomes easier for other people to understand. So, all right, so let's look at our list here. So we were talking about how it's hard to quickly understand unfamiliar code. Let's do we've got this big ugly thing. I think I talked a little bit about how I use this what's it called? Gosh, whatever, this little plugin that I put in over here to look at how I can find duplicate code more easily, and how I can see the structure of the code. I can quickly see that there's a bunch of indentation here. That's probably a problem. There's a bunch of indentation here. There's a big old pile of indentation here. So this goes and zigs way in, and then way back out, and then way back in, and then way back out, and here we do it all again. So that's probably another pile of duplication I can start digging into. So if I've got some code that's unfamiliar to me and I don't understand it now, I will say that I have looked at this code a few times and I still have no clue how it works. It's just there's just too much here. What you need to do is keep in mind how our brain works. You may have heard of Miller's magic number, where you can understand 5 plus or minus 2 concepts. That's why your phone numbers they'll have a dash in the middle and break the numbers up into groups of 3 or 4, because it's easier for us to remember those smaller groups of numbers, even though we don't have to anymore because we're using cell phones anyway. So if we can break it up into smaller pieces, it's easier to understand. So one way to do that is I can see a variable that's defined here and then see where that variable is used. Okay, so I've got a loader. I can just go looking through the code and see where the loader is used. All right, so okay, it looks like it's part of this RID loader. Here I'm checking to see whether or not it's null. Then we're setting a visibility and we finish it. Heck, I don't even know what a loader is. Maybe I should go back and see what is a loader. And I can go and see what it does and what it might need to do. That's a quick thing that you can do to start understanding some tiny piece that you might need to start looking at. Another thing that I find handy is you do a temporary refactoring. I can go in here and I can say, okay, I've got this code here. It's just a bunch of code and I don't know what it does. What if I try and I'll just do a refactor and I'll extract a method. So can I do that? I can, and it doesn't even take any parameters. So, all right, so let's, before I do that, let's quickly glance through these 12 lines of code and see what it does. It gets the current item, and then it checks to see if we've got a comment. We've got our main page adapter. We set the adapter, set the current item, and then we set the current item. All right, I mean, it probably sets the current item. So what I can do is then method, and I can say, okay, this probably sets the current item. Okay, so I've broken that out. Now I can go look at this next one here. So if it's okay, I can then see this close drawers, sets the text, clear the text from the toolbar search field. Is that what it's actually doing? You never know whether you can trust a comment, right? So finds the view by ID and it sets text to nothing. Okay, so it does clear the text from the search field, and then we hide the keyboard, get the current focus. So I'm going to clear the search field, get the current focus, hide the keyboard. If there's no view, okay, so and up here I'm going to, I don't know, close the drawers and set the text to nothing. So basically this is clearing out the search field. All right, so let's go and we'll extract our method. And it looks like we can do that too. Great. Clear out search field. Okay. I may be totally wrong on this, but that's what it looks like. So that's okay. Yeah, you put in a guardian clause. Sure, that's a great idea. What I'm trying to do at this point is I want to take larger pieces of code and replace them with method names so that I can get this to start reading like a book. So if the request code is a settings result, then I'm going to set the current time. If it's a 2001 or 2, or the result is okay, I'm going to clear out the search field. And here the search was initialized from the toolbar, return the focus to the tool. Okay, to probably turn that into a method that's called, return focus to the toolbar. I'm going to do this do result data. So if result is okay, I'm going to process the result. So I'll go in here. If the request code is 940, who knows what a 940 means? I don't know. Right. That's you're way ahead of me there. So we need to start taking these magic numbers and giving them something useful. At this point, I'm just trying to figure out, what this is trying to do. So, but yeah, I need to figure out what do these request codes mean and turn those. So this is how I can break it up into tiny little pieces. Now, I don't know if those refactorings were safe or useful, but all I need to do to undo them is go on my IDE and say undo, and I'm back to where it was before, and I haven't changed. And just say, do a get hard understanding of how this code is laid out. So those are a couple of quick and easy ways to begin to understand some unfamiliar code that you need to understand relatively quickly. Again, it's more an educated guess than having a clear understanding of it. The other thing you can do, like we were saying before, is you can write a test. Okay, I've got an assumption of how this is supposed to work, so I'm going to write a test that goes and exercises this. And then that may well become a nice little smoke test that you use on this code that was not testable before. Okay, so I wanted to really quickly go over some refactoring stuff. We've talked about some code smells. We've talked about communicating with our code and making it readable, making sure that we understand and understanding the problem domain and the fundamentals. So this is about the only thing that we've got left is understanding some fundamentals of refactoring. So with that in mind, unless anyone has, do you have any other questions or suggestions that you want to mention? Okay, so so real quickly, when you're looking to refactor some existing code, you want to, again, do everything in very small steps. Hey Max, what did you want to say?
Oh, I'd like to ask you a little question.
Sure.
Regarding, I know that you mentioned about error handling, and that we see the people trying to encapsulate the low details of some method, some resource, for example, database or external content resources and something like that, and some people trying to use exceptions to control the flow. Okay, I got it. But actually, I'd like to know your opinion about the comment that I got from the community one time ago, that it's better to be explicit than trying to then just to throw an exception. You understand? Because I saw those people saying that. We did a lot of discussion about that, because once prefer to throw out to an handler exception handler to get the catch the exception and do something, or do you think that it's better to uh, give the option to develop to the user of the method that, okay, if something happens, you can do something like that, not just throw up an exception? Right. Because as you mentioned, you need to create a function methods in order to avoid side side effects as well when something happens.
Right.
I see that when runtime exceptions happens, usually we can't retry those things because probably something failed on the process, and we don't know where happened, what's happened with the object, and maybe some object could be not more valuable state. So what do you think? You think that we need to care about the way that we write exceptions, just throws exceptions that allows to the developer that using our method that, okay, if you call it, if something happens, you will be able to do something, or just to focus on okay, if something happens, I would throw in a generic exception and go away. I think it's not a good choice as well, but I'd like to listen your opinion about that. Just like that.
Okay, well, there are a number of language specific functions and whatever commands in the language for handling control flow. You've got function calls and method calls. You've got if statements and while statements, and those are all common and all developers understand it. An exception is for an exceptional situation where something has happened and I don't know how to handle it right here. So I'm going to pass it up the line so that somebody up above who might have a better understanding can handle it. Using exceptions for control flow it's like throwing a go-to statement that can throw you any place in the application, and it will necessarily make the code harder to read, nearly impossible to test. So I cannot vigorously enough discourage you from using exceptions as control flow. So, hey, Thiago.
I have more questions. What do you think about over-engineer when we develop a code that is very couple, or you developing architecture, not follow the principal solid or the other architecture like a clean architecture or like this? What do you think about this?
Well, I don't know if you've seen here. Let me show this to you. It's very easy to over-engineer things, and that can just mess you up. There's this Enterprise, the FizzBuzz Enterprise Edition, which is just an amazing disaster. So you go into this, it's got interfaces.
I don't heard about this.
I mean, look at this. The FizzBuzz output strategy factor, solution strategy. This is over-engineering to the nth degree. And it's very entertaining to go through. And somebody actually spent a lot of time getting this to work. But yeah, a lot of times we start chasing the shiny objects and we want to do the cool new thing, and so we want to, you know, way over engineer everything, and it makes us feel smarter. We have this tendency to overcomplicate things. I just keep reminding myself that my little poo brain can't handle all that stuff all the time, and I need to keep it small, take tiny steps, and keep it simple, and then I'm able to work through the code and understand things and move forward. You know, that's really, you know, back to Kent Beck's quote that I'm not a great programmer, I'm a good programmer with great habits. So yeah, there's a danger of over engineering, and we just have to watch ourselves and hold our fellow developers accountable to avoid it. Again, you know, I keep focusing on small steps, keeping it simple. You want to start when you're refactoring with the low-hanging fruit. Keep it easy. Get rid of the clutter. If you get rid of the clutter first, then you're able to start seeing what's happening. Because until then, you're reading code or comments or just clutter stuff that's clogging up the space, and it's just in the way. Get rid of unnecessary complexity. You've got this function that does something you don't really understand. Okay, so you just go and extract it into a separate method and give it a name So that way I don't have to try and understand. I can understand this thing. Clever code, similar to unnecessary complexity. Yeah, it's really clever. It does something really neat, and you've only got one line to do it. I'm really proud of you. I'm going to go and stick that into a method because I don't know what it means. And of course, we're back to duplication, because I mean, the fact of the matter is that's how we all do our first draft. We take something that already works and we go and fiddle with it so that it does what I want. And then I've got all this duplication. The problem is that a lot of us will say, okay, my first draft is good enough, and we'll go ahead. I've got a deadline to meet and we'll ship it. Well, I don't know if you heard about what's his name? The Old Man in the Sea. Whatever, I can't remember his name right now. Incredibly talented author, wrote amazing books. They're always, thank you, Diogo. Yeah, I need to wrap things up. We're going on a little longer than I expected, but I hope it's been useful for you. And if this will be recorded, so you'll be able to see it. But anyhow, I wish I could remember. Anyway, the fact of the matter is that when he died, he had a couple of books that were unfinished, and people went back and read them, and they were awful. They were just terrible. And he used to spend months and months and months going back and rewriting his books so that they would be the beautiful, amazing classic works that they ended up being. So I just remind people that if he had to go back and refactor his books that he wrote, chances are slim that your first draft is going to be better, and you're not him. so yeah, go back and refactor. Use these built-in refactoring tools that come with the. There you go. Excellent book. Tiago's showing the refactoring book there.
Yes, my book.
Right. Yes. I've got the old original one, but yeah, actually the one that that you want to use regularly when you're moving into refactoring legacy code is Working Effectively with Legacy Code by Michael Feathers. I don't know if you've heard of this. If you haven't, this is indispensable if you're going to be working. He's got it broken up into little recipes. I've got this particular problem. I've got code that I can't add tests to. What do I do for that? I have code that it requires a tremendous amount of initialization, and I can't break out the part that I need to test. And he shows you what you need to do to handle each one, and C++ and Java and C#. So it's an excellent book that I vigorously recommend. There is a project that I wanted to dig into as a refactoring example, but we really are running out of time. But I want to at least give you the resources to get to this. Here we go. Llewellyn Falco and Woody Zuhl about 10 years ago did a presentation they called Practical Refactoring. It's on YouTube. So if you search for Llewellyn Falco Practical Refactoring, he shows you how to refactor a piece of code in little 2-minute steps. And I go back and rewatch it from time to time just because it's really exceptionally well done, and it reminds me of important things that we need to do that I sometimes forget because life happens. So I will see if I can get the yeah, I can't select it from the screen here. I will go ahead and see if I can stick these in the well, there you go. Already put it in the chat for me. Thank you, Vinicius. So if you have time, go and watch that and work through it. The code is in this GitHub project. You go to github.com, Isidore Practical Refactoring, and it's a handy little, I don't know. He's got a set of rules that you follow to do refactoring, and I vigorously recommend it. So thank you, Vinicius. You're very helpful. So that being said, for everybody here, if you want to follow me on Twitter, I'm at Scott_Wiersum, and I've got a free ebook, Low Hanging Code Smells. If you want to, it just goes over some code smells. I think Max has already gotten this, but if you want to, it goes over some of the most common code smells we run into and the refactorings that we can do to clean them up. And yeah, my brain is starting to go quickly, so I will go ahead and start wrapping things up. There's a QR code that'll take you to this this URL that gets you there. Excuse me, I'm sorry. Do you have any other questions or comments or concerns? Did I cover everything that you needed me to?
Well, I have a question about refactoring.
Okay.
So let's say I have some business problem to implement, and
Mhm.
I make the implementation, and well, I refactor the implementation.
Right.
And how do I know when it is enough to refactor? How many times should I do this iteration of refactoring?
Yeah, it's sort of I don't know, I heard some years ago that programmer is never finished, that the manager just eventually has to take it and ship what you got. You can refactor forever. You kind of have to make a call that, okay, this is good enough, and it solves the problems that we need it to. We don't necessarily have to solve every problem all the time, but we need to, you refactor to the point where it's readable, it's meeting the needs of the team that you're working on, so that they'll be able to understand it, and you understand. I guess it's going to be understandable by the next guy who's got to work on it a couple of months down the road, which may well be yourself. And so yeah, I mean, you can keep refactoring and refactoring until everything's broken up into tiny little pieces and all that, but at some point you're going to find yourself reaching a point of diminishing returns, and that really just comes with experience. You kind of figure out, okay, I have spent a week on this, and I should have just spent a day or two, and this is going too far. So does that help?
Yeah, sure. And we also should take care to avoid refactoring too much and getting to a point where you start making things worse, right? Because you can refactor and instead of improving the code, you can make it worse too, right?
Right. Yeah, and then you get into the problem of over engineering and your enterprise FizzBuzz, and you just don't want to
Yeah.
get there, because that makes it harder to maintain, even though you've gone through and technically refactored it to make it more readable. It's not more readable. It's less readable. It's harder to maintain because you can't follow where anything is anymore. So yeah, then you're moved into the world of over engineering. and you're not making the world a better place. Okay.
I have a
Anyone else?
question.
Yes, sir.
Which the other books do you recommend for studying the computer, for example, or whatever?
Well, let me look in my library here.
Okay, sure.
Now we've got the refactoring book, the original one by Martin Fowler. You've got the newer one I saw. This is another
Yes.
book that came up, this is domain-driven design, and he talks about.
This I have. This I have.
Okay, so you got that.
It's a good book.
Let's see here. There is. Oh, if you've got a bunch of changes to make in a in a program, and you find yourself, this is one of the things we talked about before, where you start making a change, and then that takes you to another change you got to make, and then that takes you to another, and it just starts to explode. This Mikado method is a technique that will help you to keep that all under control and make the changes in a way that is manageable. And so this is helpful. You might be able to pick up the technique from just reading the blog post, or if you're slow like me, you might need to get the whole book. This is handy because this is Joshua Kirivsky. He worked with Martin Fowler in putting the refactoring book together, and his idea was, design patterns are useful once you already have a program working. You can start refactoring things into following the design patterns properly. If you start writing using a design pattern from the very beginning, then that may or may not be the correct way to handle things. Let's see what else.
This book I heard about this. It's
This one?
a learning. Yes, it's a learning design patterns to write the microservice structures,
Right.
APIs, RESTful, event-driven architecture. I think it's a very good book.
Of course, Kent Beck wrote the original test-driven development book. So
yeah,
if you want to learn TDD and you want to master TDD, that's still the reference.
But before book, it's a very expensive.
Yes, it's surprisingly expensive.
It's a problem, but it's a very good.
This is one that that someone gave me a while back, and it's surprisingly helpful. It's called Growing Object-Oriented Software Guided by Tests. And so it helps you to take an existing system and add the functions that you need using TDD. And it's I mean, really the testing is what makes it so that we can keep the code maintainable and readable. And most of us, this goes over the object-oriented concepts and design principles that we were talking about before, and making sure that it's testable as well. So this is really a nice book. And I mean, I could go through my whole library, but those are really the ones that I think would be most helpful for now. Okay.
Very
Any
nice.
other questions or comments? All righty then.
Well, I have just one. I just want to hear your opinion about something I've been thinking.
Okay.
Well, nowadays we have new features in Java, like functional APIs, and later then we had design patterns. Do you think design patterns are still relevant with these new language features or not?
Well, they're orthogonal, and the design patterns have their application, and yes, I think they're still very useful. There are specific design patterns for functional solutions that aren't necessarily the object-oriented design patterns, but but I mean, if you're going to take a more functional approach to solving a problem, then yeah, follow the functional design patterns. And if you're going to be using object-oriented approaches to solving a problem, then use your object-oriented design patterns. And so yeah, it's just we've got different ways of doing things now, and that's one of the cool things about Java. It's flexible enough that we can do it both ways.
Yeah, I agree with you. I think one thing doesn't cancels the other. I think both things can like live together and help each other, I think.
Right. Yeah, we're always looking for that silver bullet, that one solution. I mean, if we wrote everything in Clojure, then the whole world would operate well. Well, except for the gaming industry wouldn't, and except for large systems that need need lots of different objects and interfaces, that probably wouldn't. And so, it's just that's the reason we've got so many wonderful languages, so many different frameworks, is because there's lots of different ways to solve a problem. Some are better than others. And the industry is still very young.
And the definition of better is on the eye of the beholder, I guess, right?
That's the
Because
truth.
for a company that has a whole code base in Java, for example, and all the developers are, they're high-end Java developers and all that, it doesn't matter if there's a language that could be better in that one specific situation. Maybe for the company doing things in Java, it's better overall, right? So yeah, so I love that. We always try to, not only we try to find a silver bullet, but we try to find a solution that is the best for everyone. And I think that everyone is going to have to decide what is actually best for them.
Right. Yeah, I used to work in real-time software, and the techniques and tools we used for real-time work is very different from the techniques and tools you use in a business environment. And so that's just the way it is. So I think we've gotten to the end. I've covered everything I can think to cover for now, and I'm gonna start coughing if I talk a whole lot more. So I want to spare you that.
That's good. So in the name of SOU Java, Scott, thanks a lot for you being here with us. If some of your friends miss that conversation, Scott has agreed to repeat this workshop in the future, right? So but and also, so Scott, you have been for people that want to grow, that they want to be better and improve their skills, are you still running those conversations that you help them analyze how things are going? And
Absolutely, yes, I am.
can you talk a little bit about that, and if anyone here is interested?
Sure. Yeah. If you're in a point in your career where you're looking for, you just want to get to that next level. If you've got some experience behind you, you want to maybe figure out, how do I become a tech lead, or just move up to a role in my team or in my company that's more responsible, and I'm able to just I don't know, have more influence in the work that I do, then I will be happy to talk with you. If you contact me, let me find my my, oh gosh, my calendar where you can set up an appointment. And yeah, I'm happy to talk with you and help you move to that next level. And I'll basically I'll find out where you're at and what your goals are, what you're looking for, and we'll come up with a plan for getting you to that next level. Best of all, it's free.
Yeah, that was my next question. So thanks for answering.
Sure. And I thought I had it right here, but I do not. Oh, I'm embarrassed.
Okay, so while you get this there, so next week, guys, on the 16th, so first of all, thanks everyone for being here, for joining here. I did announce this in the last minute. Scott has sent me early on, but he sent me on Monday, and I was traveling for the developers conference. So I apologize for announcing last minute. But for next week, next Friday on the 16th, Eyal, how do I say Eyal's last name, Scott? Do you know?
Eyal Wazinski, I think.
Okay, so Eyal, right? So Eyal, that is the author of generic algorithms book. He is the leader of the AI for Java initiative, right? So he's gonna come here and give a workshop about AI and generic algorithms, right? So same thing. If you are a associate from SOU Java, you get access this completely free, right? So it's part of our workshops that we're running around during the year. So next week, I think it's about the same time, 7 o'clock Brazil time. Eyal is going to be here, and I'm going to announce this probably during the weekend. Okay, so I'll ping you guys. Right, back to you, Scott.
Okay, so yeah, I put the link to my calendar in the chat, so you can click there and set up an appointment. If that doesn't work, again, I put my my Twitter in there, so you can contact me there.
Yeah, so what I suggest, guys, is that you click the link and leave it open on the side so you don't miss it, because once we end here, the chat's gonna disappear.
Right. Right. So
basically, what is this, Scott? Is like a 10-minute conversation, 1 hour? What is that?
Generally it's around 45 minutes.
Mm-hmm.
Depends on how many questions you have and how deep we want to dig. But generally it's been around 45 minutes when I talk to somebody.
Okay. Cool. All right. Okay, guys. If I were you, I would take the chance, right? Scott is not only he's a Java group leader, he is, he runs the Keep Calm and Refactor projects, especially for the Brazilians that want an international career. Scott is in Houston, and he works with a lot of people outside, as in offshore projects. So he has a good experience of how you can participate in international projects. So anyway, Scott's a good guy. I've been to his house many times. He's an awesome person and good friend. So thanks a lot, Scott. So I think that's it, guys.
One other thing I wanted to mention, I showed you all that ebook, that low-hanging code smells, and yeah, in that ebook it's also got this link to my thing if you want to set it up then. So if this goes away,
I would like to thank you for the invitation to participate in this meeting, Scott and Bruno.
Mhm.
Absolutely.
It's
Absolutely.
a pleasure. It's a pleasure. I like to share my knowledge and my experience, my background in software development.
Cool. Thanks,
Excellent.
Shadi.
Excellent.
Thanks.
All righty
Yeah,
then.
me too. I would like to thank you a lot, Scott, for being here, sharing your wisdom with us. And thank you, Bruno and SOU Java, for setting this up. And well, Scott, I wish you a speedy recovery. I hope you
Thank
get better soon. Thank you very much.
No cough drops. I'll be okay.
Thanks, Scott. Thanks for the effort, man. Thanks for doing this
Sure thing.
in the middle of your crazy life right there. So thanks a lot.
Yeah. Not a problem. It's been
Thank you very
fun.
much.
Thank you all for your contributions. I think it made it a whole lot more useful and helpful. And yeah, I wish you all the best and look forward to talking to you again sometime.
Cool.
All righty then.
See you, Scott.
I'll call it that. Thank
Bye.
you. All right. Good night.
See you. Bye.
Bye-bye.
Right.